In this video, we shall be solving some simple questions on quadratic equations. The first question is x plus 1 whole square is equal to 2 times x minus 3. Here we need to determine whether this is a quadratic equation. For the purpose, we shall put this equation into the standard form ax square plus bx plus c is equal to 0, where a is not equal to 0, by expanding x plus 1 whole square using standard identity a plus b whole square is equal to a square plus twice ab plus b square. Here a is x and b is 1, and that gives us x square plus twice x plus 1, and distributing is equal to twice x minus 6. Now twice x being on both sides cancels each other, and taking all terms to the left hand side, we get x square plus 7 is equal to 0. Here highest power of x involved is 2 and coefficient of x square is not 0, so this is a quadratic equation. Our next equation is x minus 2 times x plus 1 is equal to x minus 1 times x plus 3. Again we will put it in the standard form ax square plus bx plus c is equal to 0. So distributing x over x plus 1, we get x square plus x, and similarly minus 2 distributed over x plus 1 gives minus 2x minus 2 is equal to likewise x square plus 3x and minus x minus 3. Now x square is involved on both sides, so cancels each other, and transferring all terms to the left hand side, and now collecting like terms, we get minus 3x plus 1 is equal to 0, and multiplying by minus we get 3x minus 1 is equal to 0. This is not a quadratic equation because highest power of x involved is 1, so this is a linear equation. Our next equation is x square plus 3x plus 1 is equal to x minus 2 whole square. Here again we will expand x minus 2 whole square using the binomial identity a minus b whole square is equal to a square minus 2ab plus b square. This gives us x square minus 4x plus 4. Again x square being on both sides cancels out, and transferring all terms to the LHS and collecting like terms, we get 7x minus 3 is equal to 0. This is also not a quadratic equation because it does not involve any x square. In fact, this is a linear equation because the highest power of x involved is 1. In this equation, as usual, we will expand x minus 2 whole cube using the identity a minus b whole cube is equal to a cube minus 3a square b plus 3ab square minus b cube. Here a is x and b is 2, so substituting we get x cube minus 3x square times 2 plus 3x times 2 square minus 2 cube. Simplifying, we get x cube minus 6x square plus 12x minus 8. Now s cube being on both sides cancels out, and transferring all terms to the LHS and collecting like terms, we get 2x square minus 13x plus 9 is equal to 0. Here highest power of x involved is 2 and coefficient of x square is not 0, so this is a quadratic equation, though originally it appeared to be a cubic equation involving third powers of x. So it is always necessary to verify by putting equation into the standard form ax square plus bx plus c is equal to 0, where a is not 0. This is a descriptive question. Here situation has been described in words, and applying quadratic equation we have to find the area of a rectangular plot is 528 meters square. The length of the plot is 1 meter more than twice its breadth. we need to find length and breadth of the plot. So here we assume the breadth of the plot be x meters. So twice its breadth means 2x and 1 meter more means plus 1. So 2x plus 1 will be its length. Now we know area is equal to length times breadth is equal to 2x plus 1 times x is equal to area is given to be 528 meters square. Distributing we get 2x square plus x minus 528 is equal to 0. Now our problem has been translated into this quadratic equation 2x square plus x minus 528 is equal to 0. And what remains is to find values of x that satisfy this equation. So we will use quadratic formula here. Comparing with the standard quadratic ax square plus bx plus c is equal to 0, we find that here a is 2, b is 1 and the coefficient c is minus 528. Remember here always we have to take coefficient along with the sign. Now substituting in the quadratic formula we get x is equal to minus b means minus 1 plus or minus whole square root of b square that is 1 square minus 4 times a that is 2 times c that is minus 528 and whole divided by 2 times a that is 2 is equal to minus 1 plus or minus under root 1 plus 4224 over 4 is equal to minus 1 plus or minus under root 4225 whole divided by 4. And the square root of 4225 is 65, so minus 1 plus or minus 65 over 4. First taking positive sign, minus 1 plus 65 by 4, and then taking negative sign, minus 1 minus 65 over 4. That gives us 64 by 4 or minus 66 by 4 or 16 or minus 16.5. Since length cannot be negative, so we discard negative root. So breadth is 16 and therefore length will be 2 times breadth that is 32 plus 1 means 33 meters. So length and breadth are 33 meters and 16 meters respectively. In this question it is given that the product of two consecutive positive integers is 306. We need to find the integers. Here we are given two things. First is the product of two integers and secondly those integers are positive. So let the smaller of the positive integer or the first number is x. So the other would be x plus 1 because they are consecutive integers and consecutive integers differ by 1. Now taking their product x times x plus 1 that is given to be 306. Distributing we get x square plus x minus 306 is equal to 0. Now comparing this with standard quadratic ax square plus bx plus c is equal to 0, we get a is equal to 1, b is equal to 1 and c is equal to minus 306. Now substituting in the quadratic formula we get x is equal to minus 1 plus or minus under root 1 square minus 4 times a that is 1 times c that is minus 306 whole divided by 2 times a that is 2 times 1. Simplifying this gives minus 1 plus or minus under root 1 plus 1224 divided by 2. Now square root of 1225 is 35. So we get minus 1 plus or minus 35 over 2. First taking positive sign minus 1 plus 35 by 2 and secondly taking negative sign minus 1 minus 35 over 2. This gives 17 or minus 18. Since we have to find positive integers, so we discard negative value. So the two consecutive positive integers are 17 and 18. In this question we are given a train travels a distance of 480 km at a uniform speed. Here we are given two things. The distance is 480 km and the speed of the train is uniform. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. We need to find speed of the train. So let us assume speed of the train be x km/h. Then the time taken to cover distance of 480 km would be distance over speed, that is 480 by x hours. Secondly, we are given if the speed had been 8 km/h less, that is if the speed be x minus 8 km/h, then obviously the time taken to cover would be distance, that is 480 km, divided by speed, that is x minus 8 km/h. Obviously the second time would be more because the speed is less, and difference between these two times is given to be 3 hours. So the difference of two times, that is 480 over x minus 8 minus 480 over x, is equal to 3. Now multiplying by the LCM, that is product of denominators, x minus 8 times x, all the terms of this equation, and then cancelling out like factors, we get 480x minus 480 times x minus 8 is equal to 3 times x minus 8 times x. Distributing this gives 480x minus 480x plus 3840 is equal to distributing 3x square minus 24x. Collecting all terms on one side, we get 3x square minus 24x minus 3840 is equal to 0. Now comparing with the standard quadratic equation, we get a is equal to 3, b is equal to minus 24, remember to take always sign also, and c is equal to minus 3840. Now substituting in the quadratic formula, we get x is equal to minus b, that is minus 24, plus or minus under root minus 24 whole square minus 4 times a, that is 3, times c, that is minus 3840, divided by 2 times a, that is 3. Simplifying, we get 24 plus or minus under root 24 square is 576, plus minus minus becomes a plus, and the multiplication is 46,080 is equal to 24 plus or minus square root 46,656 over 6, and as a square root of 46,656 is 216, we get 24 plus or minus 216 over 6 is equal to 24 plus 216 over 6, or 24 minus 216 by 6, that gives 240 by 6 or minus 192 bar 6, or 40 or minus 32. Since speed cannot be negative, we discard the negative value 32, so the speed of the train is 40 km/h. Now in this question, we have to find the roots of the equation by the method of completing the square. The given equation is 2x square minus 7x plus 3 is equal to 0. Notice that the coefficient of x square, that is 2, is not a perfect square. So we multiply the equation by 2 and get 4x square minus 14x plus 6 is equal to 0. Now 4x square is a perfect square of 2x. So we get 2x whole square minus 14x plus 6 is equal to 0. Since the coefficient of x is negative, we will use the identity a minus b whole square is equal to a square minus twice ab plus b square. Comparing the two equations, we notice that a is equal to 2x. And comparing the second terms, we get minus twice ab is equal to minus 14x. Substituting value of a, that is 2x, and cancelling like factors, and x minus cancels minus sign, so we get b is equal to 7 by 2. Thus to convert given equation into a square form, we must add b square to this equation, that is 7 by 2 whole square, and since we are adding something, so we will deduct the same thing again, minus 7 by 2 whole square plus 6 is equal to 0. Now the first three terms convert into a whole square by a minus b whole square, that is twice x A is twice x minus b and b is 7 by 2 minus 49 by 4 plus 6 is equal to 0. Now 6 minus 49 by 4 is equal to 6 4s are 24 minus 49 by 4 is equal to minus 25 by 4. Now we transfer 25 by 4 to the RHS and now take the square root of both the sides. We get twice x minus 7 by 2 is equal to plus or minus 5 by 2. Square root of 25 is 5 and of 4 is 2. Taking 7 by 2 to the RHS, we get twice x is equal to 7 by 2 plus or minus 5 by 2. Since denominators are same, first taking positive sign, we get 7 plus 5 over 2. And secondly taking negative sign, 7 minus 5 over 2, that gives us 6 or 1. So x is equal to 3 or half. This completes the solution. Our second equation for finding the roots by method of completing the square is 4x square plus 4 root 3x plus 3 is equal to 0. Here coefficient of x square, that is 4, is a perfect square of 2. As coefficient of x is positive, we will use the identity a plus b whole square is equal to a square plus twice ab plus b square. Comparing the given equation with this identity, we notice a is equal to 2x, and to find b, we equate second term twice ab is equal to 4 root 3x, substituting value of a, that is 2x, and cancelling like factors, we get b is equal to under root 3. In order to make it a perfect square, we need to add b square, and b being under root 3, we add to this equation under root 3 whole square and subtract the same also to maintain the balance of the equation. Now first three terms converts to a plus b, that is twice x plus under root 3 whole square, and fourth term under root 3 square, here square cancels under root, so we get minus 3, and plus 3 was already there, is equal to 0. So we get twice x plus under root 3 whole square is equal to 0. Taking square root, we get twice x plus under root 3 is equal to plus minus 0. Thus x is equal to minus under root 3 by 2. X is equal to minus to under root 3 by 2. The equation has two equal roots. Our next question is descriptive and a bit lengthy. In this question we are given two water taps together can fill a water tank in 9 and 3/8 hours. The tape of larger diameter takes 10 hours less than the smaller one to fill the tank separately. And we have to find the time in which each tape can separately fill the tank. So we are given both taps together fill the water tank in 9 and 3/8 hours. Simplifying it gives 8 9 is 72 plus 3 75/8 hours. So one tank or the full tank is filled in 75/8 hours. So in 1 hour they will fill reciprocal of it, that is 8 by 75th part of the tank. It is exactly like if a tank is filled in 2 hours, then in 1 hour its reciprocal, it is filled 1/2 only. Now we assume the larger diameter tape alone can fill the tank in x hours. So in 1 hour it will fill 1/xth part of the tank. Similarly, a smaller diameter tape will fill the tank in x plus 10 hours because it is given in our question that it takes 10 hours more. So in 1 hour the smaller diameter tape will fill 1/x plus 10th part of the tank. So in 1 hour larger diameter tape fills 1/xth part of the tank plus smaller diameter fills 1/x plus 10th part of the tank. And as per question, in 1 hour they together fill 8/75. So we equate this to 8/75. Now taking LCM, we get x times x plus 10 in the denominator and 1 time x plus 10 plus 1 time x in the numerator is equal to 8 over 75. Now cross multiplying, we get 2x plus 10 times 75 is equal to 8 times x plus 10. Distributing, we get 150x plus 750 is equal to 8x square plus 80x. Now transferring and collecting terms, we get 8x square minus 70x minus 750 is equal to 0. At this stage, we have effectively translated our description into a quadratic equation. So what remains is to solve this quadratic equation, for which we will use the quadratic formula. Here a is equal to 8, b is equal to minus 70 and c is equal to minus 750. Substituting in the formula, we get x is equal to minus b, that is minus 70, plus or minus under root b square, that is minus 70 whole square, minus 4, a means 8, c means minus 750. So we get 70 plus or minus 70 square is 4900, 4 times 8 times 750 is 24,000, and the sign changes as there are two negative signs in multiplication. Whole divided by 16 is equal to 70 plus or minus under root 28,900 over 16, and the square root of 28,900 is 170. First taking positive sign, we get 240 by 16. Then taking negative sign, we get minus 100 over 16. That simplifies to 15 or minus 6 and a quarter. Since the time taken to fill the tank cannot be negative, we discard the negative value. So the larger diameter tape will take 15 hours to fill the tank, and the smaller will take 10 hours extra, that is 25. So answer is 15 and 25 respectively. Our next question is in a question form. Is it possible to design a rectangular park of perimeter of 80 meter and area of 400 meter square? If so, we have to find its length and breadth. Let us assume length of the rectangular park be A and its breadth be B. So we know perimeter of the rectangular park is 2 times length plus 2 times breadth, and that is given to be 80 meter, and their area, length into breadth, that is A times B, is given to be 400. The first equation gives A plus B is equal to 40, and the second equation gives B is equal to 400 over A. Now substituting value of B from the second equation to first equation, we get A plus 400 over A is equal to 40. Multiplying throughout by A, we get A square plus 400 is equal to 40A, or A square minus 40A plus 400 is equal to 0. Comparing with the standard quadratic, we get A is equal to 1, B is equal to minus 40. Always remember to pick coefficients along with the sign, and C is equal to plus 400. Now substituting in the quadratic formula, we get x is equal to minus b means minus 40 plus or minus under root b square, that is minus 40 whole square, minus 4 times a, that is 1, times c, that is 400, over 2 times a, that is 1, is equal to 40 plus or minus 1600 minus 1600 over 2. They cancel out each other and we get 40 plus minus 0 over 2. So by taking positive and negative sign, we get the same value, 20 and 20. So there are two equal roots, 20 and 20. So the answer is yes, it is possible to design a rectangular park with the given parameters, and its length would be 20 and breadth will be 20. In fact, it is a particular type of a rectangle, that is a square. In this question, we have to find the values of k for which the given quadratic equation 2x square plus kx plus 3 is equal to 0 will have two equal roots. Comparing with the standard quadratic ax square plus bx plus c is equal to 0, we note that a is equal to 2, b is equal to k and c is equal to 3. And we know that two roots of the quadratic are equal only when discriminant is 0, that is b square minus 4ac is equal to 0. Substituting values of abc in this, we get b square means k square minus 4 times a means 2, c means 3 is equal to 0. So k square minus 24 is equal to 0 or k square is equal to 24. Taking square root, we get k is equal to plus or minus under root 24 is equal to plus or minus under root 4 into 6, and square root of 4 is 2, so we get plus or minus 2 under root 6. So for these values of k, plus 2 under root 6 and minus 2 under root 6, this given equation will have two equal roots. Here also find the values of k for which the given equation will have two equal roots. So by distributing over x minus 2, we get kx square minus twice kx plus 6 is equal to 0. Comparing with the standard quadratic, we get a is equal to k, b is equal to minus 2k and c is equal to 6. As usual, as we know, the quadratic has two equal roots when its discriminant b square minus 4ac is 0. So substituting in this the values of a, b and c, we get minus 2k whole square minus 4k times 6 is equal to 0. That is 4k square minus 24k is equal to 0. Dividing throughout by 4, we get k square minus 6k is equal to 0. Now taking k common, we get k times k minus 6 is equal to 0, and this product can be 0 when either of the factor is 0, that is either k is 0 or k is 6. So the answer is 6, as you will notice that the k is equal to 0 does not satisfy the given equation.